Welcome to this Telit Cinterion webinar. We are calling this the IoT Playbook, what to use, when, and why. I'm Amanda Flink, the head of global events here at Telit Cinterion, and I will be moderating today. Joining me is Adam Cousin, our head of FAE and technical sales in EMEA at Telit Cinterion. Hey, Adam, thanks for joining us.
Hey, Amanda.
Now, just before I hand it over to you to start our presentation, I do have just a few quick reminders for our audience. We will have time to answer just a few questions at the end of our presentation. You can simply submit a question by posting in that questions box, which is located near the bottom of your screen. Also, please be sure to check out the resources section for some additional information. There you can find today's slide deck, a few other resources about our topic today. And finally, we will send out this replay link to all attendees at the conclusion of the webinar if you would like to look at Adam and I chat again. So anyway, with that, Adam, I will hand it to you to kick us off.
Thanks, Amanda, and thanks everybody for joining. So as Amanda said, today I'm going to talk a little bit about what to use and where and why. And this is quite a big question. Everyone I generally talk to doesn't really have a straightforward answer, and I'm not promising one today. All I'm going to do is walk you through some of the considerations that you may need to make as a system integrator or as a device maker in making the best possible decision for your market, your client, your application, whatever that might look like. So let's kick things off. And really to start, I'm going to start with bad news. It's always good to get bad news out of the way first. And this is something that's sort of hitting EMEA more than the US side. This happened in the US a long time ago, and also Australia. But in EMEA, we're actually looking at the sunset of 2G and 3G infrastructures. And this is happening kind of now. And what we're seeing is a total of 28 operators are planning on blocking 2G and 3G. Now, what does that mean? It may mean that the network infrastructure itself is being completely switched off, i.e. you're not going to see it anymore. It may well be that the infrastructure is still going to be visible, but there's going to be no roaming allowed on it. So only native SIMs, or it may be specific devices are going to be able to connect. But how this looks and what is available is going to be very much down to the MNOs. What we'd like to do is just kind of walk you through a little bit about what you need to do as a system integrated deployment provider and essentially sort out what you're going to have to do with regards to either making these devices work differently or maybe even replacing them. So from our side at Telit Cinterion, of course, we have a connectivity offering, and this gives us the ability to be able to see what our client SIMs are connecting to and what radio access technologies they're using. And what we're observing is that there's about 320,000 SIMs that are roaming on those 28 network operators right now today. Now, we can't just switch them off or switch them over, but what we can do is give you some forward warning that this is going to happen. As of October, O2 is going to be the first operator to block 2G. This is quite a big move, sort of once in a lifetime, really, for us in the UK. And they're looking at 3G blocking at the end of the year as well. So that's essentially, for anybody that's roaming on the infrastructure, that's a total discontinuation as far as the device is concerned. Swedish networks are going to follow very closely. They're going to be discontinuing 2G and 3G by the end of this year as well. So the majority of devices that are out there, and I'll give you a snapshot in a second, the majority of devices out there are not actually capable of connecting to anything other than 2G or 3G infrastructures. This means that you as a system provider are going to have to address this, otherwise these devices are simply going to go dark. So here's a snapshot. Okay, here's a picture of probably the biggest MNO by use case, and these are kind of in somewhat of an order in the left-hand side concerning our specific SIMs that we provide vendors and what they're connecting to today. And you can see on the right the modules that these are in. So you can see there's a real mix of both Telit and our competitors' devices. Because our SIMs work in anybody's products, of course, and it really is the responsibility of the device maker or solution provider to ensure that these products are managed in the right way. So as I said, this is happening now, and there may well be other operators within a territory that these devices are going to be able to roam across onto. It may well be that the discontinuation of 3G happens before 2G, or however this looks, but it must be addressed. It's important that it's addressed. What actions can you take? Ensure that your hardware can access the radio access technology that is available. So in many cases, this could be Cat 1Bs, it could be Cat 1, Cat 4, this could be 5G, could be Cat M1, could be narrowband IoT. Okay, but for sure not 2G and 3G. So make sure your hardware can access that technology. But also make sure that your SIM can access the technology. Many device makers out there deployed Cat M narrowband with 2G fallback, and a lot of those devices that were deployed actually have been using just 2G networks for the last 5 to 10 years. Has the SIM that you've put in your product actually got access to the Cat M or narrowband vendor? Have you architected your product in such a way that it can use these network infrastructures? These are things that you need to consider. In the event of a block versus a shutdown, depending on how the MNO handles it, is going to impact on how these devices behave. Okay, we saw, must have been 18 months ago nearly, when O2 in the UK decided that they were going to stop roaming on Cat M1, a lot of devices were still seeing the network, but were not able to attach, and it, depending on how the software was written, caused a kind of a perpetual loop, which ended up burning through batteries and stuff. And this was across a myriad of devices from all device makers and all SIM vendors. So it wasn't specific to any particular player. So make sure your device can handle this switch off scenario, and don't just assume it's going to go swimmingly. Things rarely do, unfortunately. If you're using a Telit SIM, then we may well be able to create a scenario for your device whereby we can block a particular network operator in a particular country in advance of this switch off, so that you can see how your device might behave. Okay, so this gives you some early warning. Now we can block it and we can unblock it, so we can basically make it stop working and make it start working again. And this will give you some indication of how your device might behave when these network operators decide not to provide the service anymore. So do speak to your local representative concerning whether or not this is something that we can do. It depends very much on the SIM type you've taken from us, but certainly we're here to help. In 2026 and 2027, there are going to be some further sunsets, and you can see here that the SIM count you see here actually are the SIMs that we provide to our customers, and what they're connecting to. So you can see, you know, Bouygues Telecom in France is a huge number of devices, as there is in SFR. So, you know, France, any French customers out there, please have a look at your estates and see what's going on, because 26 is not that far away, right? 6 months plus 6 months, 2027, 18 months. So let's talk about more forward-thinking, pragmatic things, and let's talk about the challenge of globalization. Now, when it comes to devices and how they operate and where they work, globalization is a massive issue. In many cases, it comes down to how many SKUs you want to make of a product, and how many SKUs really impacts your business in such a way that you have potentially multiple production line variants of your product needed for different areas of the globe. And you have to decide as a vendor whether you want to try and make one thing, or whether you're happy to make two things, or maybe even three things, to address the current split in network technologies that is present across the world. Clearly, if you bought a 5G, full fat 5G modem today with 4G fallback, it's going to work everywhere, but most applications can't sustain the price point of that. There's always a drive for low cost versus functionality. And the idea here is that to globalize a device, you could take a Cat M device for North America, for instance. You could take the same Cat M device in Australia, but Cat M isn't going to work very well in LATAM outside of the major towns and cities. Cat 1 works better down there. In Europe, you're looking at a Cat 1 biz story because of the availability of Cat M1 and narrowband IoT's network technology infrastructures. So where you're deploying, how many SKUs you want to make is a massive concern. And we try to make devices that are pin compatible, form factor compatible. in order to allow you to create a single version of a product to deploy anywhere. We need to look at the radio access types, okay? We need to look at whether voice is required. So some network technologies are capable of supporting voice, okay, and voice in the traditional sense. On 2G, this was circuit switched. On 4G, this is very much a packet switched service. And for 4G, sort of voice over LTE, there are special IPR considerations that have to be made. Then you've got 5G, voice over new radio. Then you've got the specification for Cat M1 that says that it's voice capable. However, of course, virtually no network operators in the world have deployed voice functionality on their Cat M infrastructure. So if voice is needed, perhaps you'd be looking at the network derived voice functionality, or perhaps you're going to be looking at a SIP service, a voice over IP service. And of course, a voice over IP service just needs a data channel, which can use virtually any bearer. Obviously not narrowband IoT because the latencies are too high and the bandwidth is too low, but certainly potentially Cat M1 could handle a SIP service as long as you're not on the periphery of the cell edge. Network sunsets, as we just discussed, so 2G and 3G, but also we're looking at 4G potentially as a network sunset scenario in North America. And by 4G, what I'm talking about is anything that's Cat 1bis and above. So for sure, you've got network operators in America now that are saying to us as module makers, we're not going to certify your Cat 1, Cat 1bis devices anymore for deployment on our networks. For a device maker, it doesn't have too much of an impact just yet because the modules that we have already approved can continue to be used, and you as a device maker can keep getting them approved in the labs and places. But for us, we can see the writings on the wall. So what devices you decide to implement for North America could be very different to the ones that you implement in Europe, for instance. And we see the rise of things like 5G RedCap in North America for sure becoming more relevant. And the relevancy of 5G RedCap in EMEA is still relatively low. It's going to get there, but it's not quite as forward thinking. Antenna complexity. So of course, once upon a time, back in the good old days, we had 5 or 4 even, 4 frequencies, which was super simple for an antenna, okay? And then 3G came along and we had 5 frequency bands, and that even was super simple. Then we saw LTE come along, and there was something like 44 different frequency bands, and then add 5G in, okay? And we've got dozens and dozens and dozens of different frequency band combinations. You've got radio interface frequency split on modems, so different RF interfaces can use different spectrums depending on, and different radio types depending on how it's functioning on, especially on 5G modules. So antenna is a fundamental point that must be raised, and trying to create something that's the size of a wristwatch that can work anywhere in the world. Of course, even the mighty Apple can't do it, because they know that the antenna cannot function properly all around the world, which is why your Apple Watch will not roam outside of the country that you bought it in. Okay, it'll work on Wi-Fi, but it won't work on cellular. That's the cellular enabled version. So be mindful that the antenna is what drives the application, and in the end, trying to globalize the antenna may well create challenges for the form factor of your product. Like I've always said, start with the antenna. Regulatory and certification, different MNOs. So you've got, specifically different regulation types. So in America, you've got FCC, PTCRB. In Australia, you have RCM and Telstra approvals, and in Europe, you've got the Red Directive. And everywhere else in the world kind of takes, Anatel in Brazil, obviously, but everywhere else in the world kind of takes its view from one of those kind of 3 or 4 major certification types, and that creates a natural split across the world with regards to regulation. And these different territories have got very different requirements when it comes to spurious emissions and when it comes to antenna efficiencies and spectrum usage and things like that. So be mindful when you're designing something. When it comes to globalization, there may be challenges faced, and for sure there are things that can be overcome by SIM choice. Okay, so For instance, in North America, you can put a purely roaming SIM in, which means that you don't need PTCRB or local network operator approval. You can just go for your FCC, which is the legal bit, and deploy with a roaming SIM card. But be advised that if your deployment scenario exceeds a certain volume, critical mass of devices, or starts using too much network resources, the MNOs may well come to you and say, we need you to go through the full-blown, full-fat regulatory and MNO compliance testing in North America. So it's not as plain sailing, but certainly for an initial deployment, you could just choose a roaming SIM. Then there are difficult countries, okay, and difficult, I mean, there are places in the world where the government has decided to not allow or make it challenging for roaming scenarios, for devices to be deployed with roaming SIMs, or even fundamentally increasing the cost of a roaming SIM card versus a local MNO one. And this introduces challenges for device makers who are providing SIMs in the product, because it means that maybe in those countries you have to pick a local SIM vendor in order to make the system work long term. So these are the challenges of globalization. I didn't promise you an answer, but these are the things that you have to think about as a device maker. And for sure, we're here to help guide the decision and help down the path of making a product that works properly. Let's talk a bit about network technologies, and we talk about Cat-M and narrowband or Cat1bis, and there's a lot of hype at the moment, certainly around the Cat1bis story. And really, we have to look at the application to determine whether or not this is something that's going to be useful or not, whether it's going to solve a problem or create more of a problem than you've already got. Okay, so I speak to people all the time concerning their applications, and certainly Cat1bis is a massively cost-effective technology. It removes a lot of the complexity around roaming, for instance, because a lot of the network operators out there that are monetizing their Cat-M and narrowband infrastructures now in different ways by separating off their IoT divisions of their business from their consumer divisions, so the bits that service the mobile phone technologies. Cat-M and narrowband find themselves very much in the IoT division, whereas Cat1bis is still fundamentally in the mobile phone side of things, the consumer side of things. And what it means is that if there is a roaming challenge, if there's an access fee or charge or something pertaining to accessing this special IoT infrastructure, it almost certainly won't be the case for Cat1bis, because that is very much more open. And of course, any operator that supports 4G will support Cat1bis. So you may go from having one or two operators in a country that can support one or both of Cat-M and narrowband to having maybe 4+ network operators that will all support Cat1bis. So naturally, there's coverage improvement capability there simply from a roaming and a cost improvement there, because you don't have access charges. However, if your application is something that is sited below ground with a very, very bad antenna placement, it may well be that Cat1bis simply isn't going to give you the signaling capability that Cat-M and narrowband, especially narrowband, can give you in those incredibly harsh underground environments. Power consumption, if you're looking at applications where you're static and you're switching on every 15 minutes, sending data and switching back off again, okay, clearly there are power saving techniques available in Cat-M and narrowband, power save mode, EDRX, that allow you to intelligently control the modem and bring it up and down in a fashion which is synergistic with how the network operates, which really does improve current consumption. Something where with a Cat1bis modem, for instance, you'd have to just dosh the power on and off all the time on the modem, which doesn't actually save any power because it goes through a full reboot cycle each time. So power saving, if you're in a mobility environment, of course, power saving is nonsensical. It doesn't make it, EDRX and PSM mode don't work in mobility, so they have to be stationary. But if you've got an application which is a tracking type application or something where you're doing anything that's mobile, Cat1bis certainly has strength in so much as, like I said before, the network coverage, but also it supports full mobility, which is something that narrowband IoT can't do. And of course, the aforementioned roaming challenges, if you're crossing borders, Cat1bis may well give you a better experience crossing a border than using narrowband IoT or Cat-M1, for instance. Bandwidth, narrowband is probably the lowest, then it's Cat M1, then it's Cat 1 Biz. So if you've got a relatively bandwidth intensive application, then for sure Cat 1 Biz is going to give you a higher throughput. Okay, it's the same as Cat 1. It's 5 megabits upload, 10 megabits download. Cat M1 is hundreds of kilobits per second, which is usually perfectly fine for most IoT applications. And because the spectrum it uses is generally sub 1 gigahertz, actually the coverage on Cat M1 is pretty good. So bandwidth wise, if you need more throughput, then Cat 1 Biz is a good option. But if you're fine at the lower end, narrowband IoT really is your bits and bytes sensor data, then stick with that. Size of product. So historically, Cat M and narrowband devices have been smaller. Okay, in our own portfolio, we've got narrowband and Cat M devices that are down in the 14 by 13 millimeter sort of size range, maybe up to 15 by 18, but that's in a kind of scalable nested footprint. Cat 1 Biz have traditionally been a little bit bigger. However, that's changing. We've got Cat 1 Biz coming out in the small form factor as well. So I guess size isn't so much of an issue. But if we look at the antenna, okay, and the complexity around it, Cat M, narrowband IoT tend to operate in the sub gigahertz band, right? So you may be down at 700 megs or 800 or 900, as high as band 3, 1800 for EE in the UK. But what it means is the ground plane size, in order for it to work effectively, is traditionally bigger for those lower spectrums, whereas Cat 1 Biz maybe doesn't need to use or rely on those lower spectrums quite so much. But then making an antenna work on a network in a country, you may only need to pick one frequency. Maybe it's only band 8, or maybe it's only band 20. So your antenna can be super simple and optimized for that particular frequency, rather than trying to create an antenna scenario that works well across all spectrums. And this really is where an antenna tuner chip can come in to try and ultimately dynamically adjust how an antenna performs based on what the RF side is being asked for from the network side. So we have antenna tuner scenarios in our modules using external componentry. You can talk to us more about that, but really they're there to try and optimize what is effectively an almost impossible scenario, which is trying to make a globally well-performing product. Let's talk about a little bit RedCap now. So I mentioned it earlier on as something that's really gaining traction in North America, and 5G RedCap, which stands for Reduced Capability, is a Release 17 standard from the 3GPP. And the initial release, what we're talking about is a technology which is designed to replace the mid-speed IoT products. When 5G was first envisaged, there were 3 main pillars of operation. There was the massive machine type communications, which you can see down in the bottom left-hand side. And this really is where your Cat M and narrowband IoT type devices come in. Mass deployment, billions of devices, but all transmitting very small payloads of data, so not consuming too much network resource. Then you've got your high throughput, so your EMBB, enhanced mobile broadband, at the top there in the royal blue triangle. And this is your mobile phone, these are your broadband routers, fixed wireless access, dash cams, gateways, gaming applications, anything that's kind of a bit more, I guess, consumer oriented, okay, for what everybody thinks 5G is, which is fast, high bandwidth, high cost. Then you have the triangle down on the bottom right, which is the ultra reliable low latency connection. Don't try and say that after a drink. This is really for private implementation 5G scenarios. So this is, where you've gone to Nokia or one of the other network providers and said, I'd like to implement my own private 5G infrastructure, maybe within a factory, for factory automation. And this is where you can really closely control the latency and have devices which are able to really quickly operate and react to scenarios that are relevant for those kind of infrastructures. Clearly on the public infrastructure, having low latency is very challenging because you've got just a massive users and an ever-changing payload requirement, and private usage really for ultra reliable low latency. The middle bit was never really addressed, and this is where Cat4 has sat, and this is your your industrial sensors, your alarms, your e-health type applications, something that needs voice. It needs more bandwidth than mass machine type, but much less bandwidth than enhanced mobile broadband. Okay, maybe it needs a bit of voice. Certainly doesn't fall within the ultra reliable low latency spectrum, but really it's a Cat4, Cat1 type replacement scenario. And the initial release of release 17, RedCap, would see something in region of 200 megabits per second for 5G operation. But what you have to be aware of is that it is a dual antenna. I mean, single antenna is considered, but really it's a dual antenna scenario. So a far cry from the 4 antennas of traditional 5G. It's designed for single band operation. What does that mean? Single band means that it's not a carrier aggregation product. Okay, so carrier aggregation typically means you have higher throughput because you can use multiple carriers. This is a single carrier type technology. Okay, so you aren't going to get more than about 200 megabits per second through. It requires a standalone 5G network. Okay, so it must be release 17 and it must be standalone. By standalone, you have a 5G network core and 5G radio access towers. Okay, if there's any 4G involved in there still, then you have a non-standalone, an NSA implementation from the network side, and typically these 5G devices need a 4G anchor band in order to connect, and 5G RedCap is not designed for that type of operation. For sure, these 5G RedCap devices initially will have 4G capability as well, but there's no real interoperability between the 5G and 4G radios. They should be considered almost independent from each other within the modem, and almost a manual operation to switch between the 2 radio access types. There are some very rudimentary power saving options, but for sure nothing like the massive machine type communications element requires. So don't consider RedCap to be a replacement for Cat M1 unless you need higher bandwidth. The release 18 standard that's coming out is the evolution of this, and of course this is going to evolve through time, and really what we see is this addresses more the even lower bandwidth requirements. And now we start kind of encroaching a little bit more onto the massive machine type communication side, because these devices are likely to be single antenna. We've yet to have confirmation, but single antenna is desired. They're likely to be a bit smaller, okay, probably lower cost. We certainly see the price points on these things coming down, but importantly they're going to have some extended power saving options, which could make them very interesting for the likes of metering type vendors, people that really need devices that are going to function for the long term on the infrastructure, but maybe not have to rely on the IoT specific network types, KM and narrowband IoT. Do you really need an eSIM? So there's a lot of hype. What is an eSIM? You know, somebody says to me, I need an eSIM, and I kind of sit there, head in my hands, and I say, why? For sure, there's a huge myriad of reasons why an eSIM is tremendously important. Unfortunately, in a lot of cases, these are not really the reason why people want an eSIM. Usually there's a lot of hype behind it, but actually a lot of reality hasn't been explored properly. So if we look at the whys, this could be an insurance for the future. Okay, so commonly I don't want to be locked into a vendor. Okay, I'd like to be able to change vendor in the future. Okay, that's fine. Maybe there's roaming challenges. Maybe you're worried that you're not going to be able to roam on a particular network type, or maybe you need an eSIM because you're going to go to Turkey and you need to put a Turkcell profile in, and that's completely legitimate. Okay, but an eSIM is not designed for you to be able to dosh new profiles in at a moment's notice, and as you cross a border, put a new profile in and then switch. And I had a rail operator in Central Europe talking about using an eSIM and putting a different profile in and having it switch profiles when it crossed borders to try and optimize cost. And of course, it's not really designed for that. It's not really meant to be done quickly. It's over time. Bring your own connectivity, and this is probably the most legitimate reason. Okay, and we have many metering vendors out there who want to make millions of something. Okay, and they want to build the device with the SIM technology inside, sealed up, maybe IP enclosed, so the user can't access it, but on the production line, program in the MNO profile. So maybe these are going to, you know, France and they need an SFR profile inside. Maybe they're going to the UK and they need a Vodafone profile inside, because whoever is owning that metering product in the end as the electricity provider has got a contract with the local MNO and they need their profile put in. And this is something completely legitimately that can be handled by most eSIM vendors, us included, okay? And we provide that capability to people's production lines and they can program these SIMs to their heart's content. B to B to C, so business to business to consumer. And, you know, we see some of this where maybe a device is initially sold out business to business, connectivity is provided, but they want to be able to give the client the opportunity to put their own SIM profile in the future and take responsibility for the ongoing running and cost of that device. Again, a totally legitimate use case in this scenario. And then, of course, you've got the bill of materials and logistics, which we go back to the meter vendor. They just want to make one thing, right? Globalization. How do you globalize a SIM? We put a SIM in that doesn't have a profile inside it, right? So maybe the BOM logistics. So the options that many people consider here is, I don't want the user to be able to remove the SIM. That doesn't really need an eSIM. That just needs a chip SIM. It doesn't have to be an eSIM. I need to port or conformal coat my device. Again, it doesn't really need to be an eSIM. It's useful for it to be an eSIM because when you port or conformal coat something, it's thoroughly inaccessible. But if you're planning on having a particular profile inside, it doesn't have to be an eSIM if you're never planning on changing. Or I just want a solderable component. Again, it doesn't need to be an eSIM. It can just be a normal multi-profile SIM card. So really explore why you want an eSIM before going down the route, because there is a lot of smoke and mirrors out there, and there's a lot of talk of standards like SGP32 and the older SGP22, and there's a lot of hype, but the reality is really you need to understand what you want to achieve by using it. NTN. So this is something else that's very much on this kind of hype curve at the moment. Non-terrestrial networks, and there's loads of people out there that have been using companies like Iridium for years for satellite communications radios. Okay, hugely successfully. All right, that's not NTN. All right, now, maybe the satellite networks can be used by NTN, but a satellite-only radio is not an NTN product. NTN is a standard, again, derived by the 3GPP for the ability of a cellular, so an inherently cellular modem, to be able to transact information via a satellite, so a non-terrestrial entity. And that could be a full-blown base station in the sky, right, that handles the registration, or it may just be a relay. Okay, so as you can see on the image in the middle, you can see that you've got devices maybe in mountainous regions that are using satellites simply as a relay back to a ground-based network. Okay, and this is very much where we are. Or you might have a G node B in the satellite itself, which will allow inter-satellite communication, but also you wouldn't necessarily have to have a local registration on the ground. This is something that could handle the registration as well. And really we come down to the use case and the latency, because a relay scenario introduces huge amounts of latency, whereas a G node B maybe is a little less latency heavy. But in the end, the idea of NTN is that it can provide true globalization to cellular without having to rely on local base stations and coverage for humans, which is what normally cellular is based on when you see it's population coverage, but population is not necessarily where things end up. Okay. So what do you need to know? What do you need to use it for? Everybody talks about NTN, but actually what do you want it for? Why do you need it? What's the problem you're trying to solve? Okay. Now, clearly NTN is going to work in some applications better than others, and being a satellite-based technology, generally you need a good view of the sky. So if this thing is underground, you need to make sure at least your antenna is outside the ground. Okay, it's not going to work in a heavily dense environment where the satellite cannot be seen. Stick this thing in an urban canyon in a major city and try and use it with a geostationary satellite. it's not going to work because it can't see the satellite, right? It might work with a MEO or a LEO type constellation because the satellites will be passing over, but there are considerations to be made. Okay, so what do you want it for to start with? Then we need to look at constellations, so low Earth, medium Earth, or geostationary Earth orbit. And these different satellite constellation networks are going to have very different use case needs for the application on the ground and also the bandwidth capability. So most of what's available today, right now, is going to be a geo type system. So you look at companies like Skylo, they're using the Astra satellite system, which is a geo satellite. So if you've got Sky TV, for instance, you know your satellite dish has got to be pointed in a place in the sky all the time. And that's what a geostationary satellite is. It, depending on where you are in the world, it sits at a varying degree off the horizon because geosatellites typically orbit the Earth around the equator. So if you're in the northern hemisphere, you're closer to the horizon. In the middle of the hemisphere, then it's directly above you. Okay, and then in the south, it's the other direction. These satellites generally are further out. The latency is a bit higher, the bandwidth is lower, and really it's more for narrowband IoT type replacement technologies from a geosatellite perspective. LEO and MEO are going to bring in some higher bandwidth capability. Antenna and spectrum, okay, we'll talk about that in a minute. What provider? So there's a lot of providers out there for this. There's loads of startups, there's people throwing birds in the sky, there's all sorts of stuff going on, all right? It's a bit of a mess, and we expect there to be some sort of consolidation as time moves forward. But what provider's super important? Interoperability. Are these providers actually talking to each other, or are they all trying to reinvent the wheel? Okay, so how do you make something that's interoperable? And then subscription. How do you access these infrastructures? Now, clearly, if you've got a cellular product, it's got a SIM card inside. But we go back to, can the SIM access the NTM vendor? How do you get the NTM vendor's profile on your SIM? Does your profile provider, so whoever you're with, have they got a roaming agreement? Because these are coming in now, roaming agreements with NTM vendors. And who is it? And then, is your antenna able to actually transact information with that particular NTM provider? Because they all run subtly different spectrums, S-band, L-band. I'll talk about that in a second. So if we look at frequency range up to 7 gigahertz, this is your normal, typical IoT type antenna scenario. You've got geo and LEO and MEO potentially, but really this is narrowband IoT. Okay, utilities, agriculture, things that are somewhat static, things that aren't really moving around too much, but very low bandwidth. If we look at handsets, smartphones, cars and drones, it's a few megabits per second. This is very much the LEO and MEO side of things. You're not going to do this with a geo satellite. Okay, it's 5G new radio, so this needs a full fat 5G product, whereas the aforementioned geo type system for Skylo, this just needs an NB-IoT or an enhanced machine type communications standard, so EPC based. Whereas with the LEO MEO handset application, it really does need a 5G radio. Okay, and this is for automotive, utilities, agriculture, public safety, defense, things like that. And then you've got your frequency range above 10 gigs, which is your VSAT. This is hundreds of megabits. This is proper mobile broadband, satellite based. It could be handled by geo, LEO and MEO, so any of those constellations. It needs 5G new radio. Okay, but the antenna implementation is going to be very, very special for these types of systems. Okay, and certainly for LEO and MEO type satellites, these are in motion. Geo is stationary, so you just need to make sure your thing can see it, and it'll always see it. As long as there isn't an alien spaceship in the sky, it's always going to see it. LEO and MEO, the satellites are constantly moving, and what you have to be aware of for your application on the ground is that you're going to need very specific timing. You need positioning information. You're going to need to have the almanac information for where those satellites are in the sky so that you can calculate the pseudo range, the Doppler. You're going to have to start talking about, really ephemeris almost, because you're going to have to be able to hand over from one satellite to another in order to maintain communications. And of course, the antenna scenario for that becomes complicated as well. So we need to back it up a little bit sometimes. It's all cool, but we need to work out exactly how it's all going to work. So really, we're here to support you. Okay, a lot of what I've just talked about there is not specific to Telit Cinterion. It's more about architecture and what to think about, and the sort of stuff that runs through my brain constantly, which is incredibly boring for those around me at home, but at work it's very useful. But yeah, really, as an organization, we are here to support you in implementing the right technology to meet the needs of your application. Because clearly, if you don't, then you're not going to sell anything, and neither are we. So we're all on the same page. We can help you with modules, we can help you with connectivity, we can help you with platforms, with solutions. We have turnkey products and terminals, even with regulatory approved devices, pre-approved products. We can help. We're here to help. So with that, I'm going to hand back to Amanda, who is waiting in the wings, and I'm sure she's keenly monitoring the audience.
You got it exactly. Thanks, Adam, so much for all that info. Just really quick, audience, before we get to some of those questions, I am going to drop a poll on your screen right now. If you would like to have one of our experts contact you, maybe you've got a really specific question or something about your application that you'd like to talk about one-on-one, if you'll just respond here on the poll, I will be sure to connect you with someone. Maybe even Adam, if you're lucky.
Lucky.
All right, so we will take just a few questions today. Trying to keep this kind of nice and short. And we've gotten a couple. So Adam, I'll just dive right in here. First question says, my SIM provider said my SIM is 4G and 5G capable. Will my modem just work?
So, yeah, it depends on a few things. So the SIM being 4G and 5G capable is great. Okay, that's a super good start. But if that SIM's inside a 2G, 3G modem, then the answer is no. Maybe the SIM's inside a Cat-M narrowband modem, which is great news. It means your hardware's there. Maybe when the SIM vendor says it's 4G capable, perhaps they mean Cat-M and narrowband, but go and get clarification, all right? Don't just assume it's going to work. Work out who it's going to be roaming onto in your region. And when it comes to things like narrowband and Cat-M, you really should decide what your device is going to connect to. Don't let the modem make the decision. It may well be that somebody inadvertently in firmware, in code at some point, told the modem to only work on 2G. Okay, so there are AT commands from all modem vendors that say, I only want to work as a 2G modem. All right, and which would have been a super good idea because it would have really simplified the way these things work in the field while 2G was still available. Now it's disappearing. That decision needs to be undone quickly, especially if the device is capable of working on the infrastructure. So really, you need to look at your application layer. You need to look for the things that are gotchas, things that are going to potentially bite you in the backside, not because they were the wrong decision at the time, but because they're maybe the wrong decision moving forwards. And just make sure it's all going to work properly. And then, of course, the antenna. If you decided your device should only work as a 2G modem 5 years ago when you bought the modems, maybe you only put a 2G antenna on it as well, and the antenna is actually not capable of transacting at 700 megahertz or 800 megahertz. Maybe it's 900 and 1800 only. So you need to look at all these things in order to make an informed decision, and don't just take the flippant answer of a connectivity vendor that everything's going to be all right.
Perfect, thanks. Next question I have says, I have an eSIM. Can I change profile to make my devices work again?
Right. So I would start, if I had this person in front of me, I'd start with, well, what type of eSIM were you sold? Is this an SGPO 102 or is it an SGP22 solution? Because it's very different, very, very different standards. Okay. How are you, if it's SGPO 102, then the good news is that this is handled through basically a platform which is able to alter the APN of the application and it's all done through SIM application toolkit. So there really is very little needed on the application side in order to change the SIM profile, other than a connection, okay, and the device being on for long enough in order to be able to download a new profile and be connected to a radio access type that can allow that kind of transaction. But what profile you can put in really comes down to the SIM vendors onboarding of different profiles. Okay, so it may well be that it's I don't know, an IDMIA SIM or something like that, and actually you're kind of restricted as to whose profile you can put in. But if it's SGP22, then the answer again is yes, but you need to look at APN management. Okay, so if you change the profile on an SGP22 device, then you need to make sure that the APN in your application is set properly. Otherwise, the new profile is going to try and use the APN of the old vendor. It ain't going to work, right? So the answer is yes in both cases, but again, it comes down to architecture and what you were sold versus what's deliverable.
Adam, you are such a wealth of knowledge. Thank you so much for walking through that. I think we will wrap up there. I realize that we've got a couple other questions, but we can go through some of those one-on-one directly after the webinar. Again, please be sure to check your inboxes in the coming days if you'd like that replay link. Maybe your colleagues would like to look over this. Resources in the resources section for some additional information. And Adam, thank you so much for your time today. I really appreciate it.
Pleasure. Thanks, Amanda.
Yep. Have a good one.